Now, suppose we're asked to graph f of x as negative x cubed plus 9x squared minus 15x plus 5. Again, to find the maximum and the minimum point where the first derivative is 0, or in other words, the slope of the tangent line is 0, then we have to get the first derivative. And getting its first derivative, we have x squared plus 18x minus 15. We may factor negative 3 out. Minus 5x minus 1. So setting this to 0 again to find the maximum and minimum point, we may ignore the constant here. So that gives us x minus 5 as 0 and x minus 1 as 0. Thus, the values of x are 5 and 1. Again, these points are what we call the critical points. These are points of the graph where the maximum and the minimum points lie. So suppose this is 1, 2, 3, 4, and 5. Somewhere here will be the maximum or the minimum point, and somewhere here will also be the maximum and the minimum point. Let's perform the first derivative test. Again, the first derivative test is where you partition the graph based on the critical point. So we have 2 points here. That makes us having 3 partitions. One from less than 1, another one from 1 to 5, and another one from 5 onwards. So let's start with those values less than 1. So substituting a value that's less than 1, the easiest is 0. On the first derivative, this 1. So we have negative 3 times 0 plus 18 times 0 minus 15. So that is negative 15. So that tells us that since the slope of the tangent line here is negative, then the graph is decreasing at this interval. Next, on the other interval, let's have the interval from 1 up to 5. So from 1 to 5. So let's take a value, any number between 1 to 5. Let's take 2. So substituting 2 on the first derivative, so we have negative 3 times 2 squared plus 18 times 2 minus 15. So that is negative 12 plus 36 minus 15. So that is 9. So that's positive. So this tells us that the slope of the tangent lines here are positive, indicating that the graph is increasing. Next, let's take this part of the graph wherein x is greater than 5. So let's take a value that's greater than 5, suppose 6. So substituting 6 on the first derivative, so we have negative 3, 6 squared plus 18 times 6 minus 15. That's negative 108 plus 108 minus 15. So that's negative 15, so this is negative. So this tells us that since the slope of the tangent lines here are negative, then the graph here is decreasing. So next is, let's get the ordered pair of the critical points. Simply substitute 5 and 1 on the original equation. So we have, let's take 1 first. If x is 1, so that's negative 1 cubed plus 9 times 1 squared minus 15 times 1 plus 5. So that's negative 2. So we have a point which is 1, negative 2, which is either the maximum or minimum point. Next, if x is 5, so f of 5, we have negative 5 cubed plus 9 times 5 square minus 15 times 5 plus 5. So that's negative 125 plus 225 minus 75 plus 5. That is 30. So we have a point which is 530. So we have 1, negative 2, let's say this is this point, and 530, let's say somewhere here. So this is 530, and this is 1, negative 2. So again, at this point of the graph, it's decreasing. So we have a graph that looks like this, and then it will increase based on this, and it will decrease again. So this point, 1, negative 2, we know that that is the relative minimum. And the maximum point here is 530. Again, these are the relative maximum and relative minimum points. Moving on, let's now have the second derivative. So again, the first derivative is negative x squared plus 18x minus 15. So the second derivative is the derivative of the first derivative. So that's negative 6x plus 18. So solving for x when this is 0, so that gives us x equals 3. Again, this 3 is what we call the point of inflection. So meaning, somewhere here at 3 will be the point of inflection. So if you want to get the actual point of inflection or the ordered pair of the point of inflection, simply substitute that value to the original equation. So when we substitute that, that will be negative cube of 3, 9 of the square of 3 minus 15 times 3 plus 5. So that's negative 27 plus 81 minus 45 plus 5. That is 14. So we have a point of inflection which is 314. Again, the point here is 314 is the part of the graph where the tangent line changes its direction from counterclockwise to clockwise or clockwise to counterclockwise. Okay, the second derivative test will partition the graph into two parts in which the division is 3. So we're going to get the second derivative of those on the left of 3 and those on the right of 3, meaning the values less than 3 and greater than 3. So let's substitute some values of x which is less than 3 on the second derivative. Let's take 0. So substituting 0 on the second derivative will give us a positive value. And for x greater than 3, let's say 4. So the second derivative is negative 6 times 4 plus 18. So that's negative 24 plus 18, which is, so that's negative 6, which is negative. So since this is positive, on the left side of 3, meaning the value is less than 3, which is this graph, it is concave upwards. The values greater than 3 or on the right side of 3, since this is negative, the graph is concave downwards. So again, the inflection point is the part of the graph where the shape of the graph changes from being concave upwards to downwards or from downwards to upwards.